Renaissance astronomers described the solar system as a giant clockwork mechanism in which a series of cosmic interlocking gears determine the movements of the planets. But we now know that the orbits of the planets are not as fixed as they appear.
It seems so steady, it seems like it is this clockwork, but there are ways in which it can be disrupted quite dramatically.
Even a slight change in the Earth's orbit could severely impact our ability to survive, since the position of our home planet makes it uniquely suited for life.
The Earth seems to be an ideal planet in terms of habitability because it lies at just the right distance from the sun, in which point liquid water can be stable on our surface. We can have oceans and lakes and rivers, and we think that water is really the key ingredient for life.
Earth is in that special zone. It's not too cold, nor too hot, it's just right. If we were closer to the sun, we might end up like Venus, a planet too hot to live on, with a temperature hot enough to melt lead. On the other hand, if we were farther away, we might be more like Mars, which is just ridiculously cold, and you can't support life when you're too far from the sun.
But what would happen if Earth's delicate balance were disturbed, so that it was no longer this perfect distance from the sun? Far beyond our solar system, there are planets wandering through the galaxy, not bound to the gravity of any star. Known as rogue planets, they were ejected from their birthplace by unstable orbits or cosmic collisions and sent on wild trajectories through the universe.
Essentially, a rogue planet is a planet that was originally in a different star system, and it was kicked out and is now wandering the cosmos, divorced from its parent star.
There's likely to be at least as many planets as there are stars. So we expect there's something like 100 billion stars in our galaxy, and so we expect a couple 100 billion of these rogue planets.
These rogue planets are interstellar nomads, cold, devoid of life, and careening through the darkest reaches of space. And many of them are likely to be giants, hundreds of times larger than Earth.
Right now we're seeing more so-called Jupiter-sized planets than others. Based on that, you could expect an average rogue planet to be on the order of a Jupiter-sized planet, maybe less.
With billions of rogue planets in our galaxy, it's possible that one could swing through our solar system with monumental effects.
A rogue planet coming into the solar system will probably be moving at hundreds of miles per second.
It's possible that a rogue planet could hit the Earth directly, completely demolishing our planet. But a rogue planet would not even have to get near the Earth to create havoc.
The nightmare scenario is that one of these large rogue planets drifts right through our solar system and ends up disturbing the orbit of one or more of the larger planets. And because these larger planets, like Jupiter, actually help shepherd the inner planets, it ends up elongating the inner planets' orbits, which would dramatically change things for life on Earth.
It's almost like taking a baseball bat to the Earth, the rogue planet being the bat, and just the force from this planet will be so great that you just change the path of the Earth just in the same way that a bat can change the path of the baseball on its way to the catcher's glove.
And if Earth's orbit were elongated just enough to swing outside the habitable zone,